Do question 2 from the worksheet that I gave you, which is question 6 from 2013. Okay, so you'll need to have that in front of you. Niamh has saved to buy a car. She saved an equal amount at the beginning of each month in an account that earned an annual equivalent rate of 4%. Show that the rate of interest compounded monthly, which is equivalent to an annual equivalent rate of 4%, is equal to 0.327. Okay, so what we're saying is if a sum of money was put away for a year, at the end of that year with an interest rate of 4%, we know that what you would get at the end of that year is P plus 4%, which is P times 1 plus 0.404 at the end of the year. Okay? We want to know now if you put P in and instead you put it in and every month you got an interest added on, and we'll call that interest rate I every month, you want to get the same amount out at the end. So you want the rate per month that's equivalent to getting 4% at the end of a year if you just left it in for the year. But we know if we put P in with an interest rate of I being added on every month, we know that we would have out at the end P times 1 plus I to the power of 12. So in this situation, we want P times 1 plus I to the power of 12 to be equal to P times 1.04. Actually, we can just divide the two P's out. So 1 plus I to the power of 12 is equal to 1.04. We need I, so the first thing we need to do is get the 12th root is equal to 1.04 to the power of 1 over 12. Or we could have said the 12th root of 1.04. The problem is that sometimes these numbers get written too big and somebody thinks they're multiplying by 12. So I will be 1.04 to the power of 1 over 12 subtract 1. And that works out to be 0.00327, which is the interest rate as a decimal, remember. So the interest rate as a percentage is 0.327%. Okay, that's the first part. The next bit. Right, Niamh. She has 15,000 in the account at the end of 36 months. How much has she saved each month? Correct to the nearest euro. So she basically is saving every month. She is putting S away. And we know that at the end she has what's known as H. Now, we have to be careful here. At the end, how much she saved each month? At the very start of the question, it says she saved an equal amount at the beginning of each month. So her money was going in at the beginning of every month. Okay? So we know she collects her holiday fund, no, it's not her holiday, whatever it is, her 15,000 for her car at the end of the last month's payment. Okay. How much has she saved each month? Correct to the nearest euro. So we now know that the interest rate per month that she is getting is 0.327. Isn't it 327%? Yeah. Okay. So this S is worth S times 1 plus the interest rate as a decimal. So 1.00327. That's 1 plus 0.00327. Okay, 1 plus the interest rate as a decimal. As we go further back, the second one, the payment before that will have been S times 1.00327 to the power of 2. That's what that payment will be worth by the time she collects. And going the whole way back, then her very first payment, having been in there for n months, will be worth S times 1.00327 to the power of n. And we want to find the S such that the sum of all of these contributions adds up to the H that she wants. So this will be worth this in a month, this will be worth this in 2 months, this will be worth this in n months, and so on. So the sum of all of these has to give us the 15,000 that she wanted, her holiday fund or her car. Okay, so that is a geometric series. The A of the geometric series is S times 1.00327. The R is the multiplier or the common ratio, which is 1.00327. And the H, we know, is 15,000. That's how much she wants to have at the end. So H, 15,000, is Sn, which in this case is A times 1 minus R to the power of n over 1 minus R. So we literally just fill in the values here. So we have 15,000 is equal to A, which is S times 1.00327, A times 1 minus R to the power of n. Now, what's n in this situation? N is the number of months, so the number of months is 36. So n is 36 in this question. 3 to the power of 36 over 1 minus R. Okay, so we just want to find the S. Okay, so S, we multiply both sides by that, so 15,000 multiplied by 1 minus 1.00327 is equal to S times all of that. So S is this divided by this piece here, divided by 1.00327 times 1 minus 1.00327 to the power of 36. And when you put that into your calculator, you get 392.02. So that means that if she puts away 392.02 euros every month for 36 months, then at the end of that 36 months, she has the 15,000 to buy the car. Okay?